Hello.
Yes, sir.
Parikshit,
Yes, sir.
your audio has come is very low now.
I'll raise a little bit high pitch. I'll speak.
Okay.
uh,
So,
good morning, everyone. So let me welcome Professor Navneet Goyal, sir. He's a professor in Department of Computer Science and Information Systems, BITS Pilani campus. I'll briefly introduce sir that his MSc is from mathematics from Hemwati Nandan Bahuguna University in 1988. MPhil in Applied Mathematics, Department of Mathematics, University of Roorkee, now IIT Roorkee, and a PhD in Vibration Theory, Applied Mathematics, Department of Mathematics from University of Roorkee, from IIT Roorkee, now IIT Roorkee, and PG Diploma in Health Systems Management, Tulane University, Health Sciences Center School of Public Health and Tropical Medicine, New Orleans, Louisiana, USA. Welcome, sir. Sir will be delivering the case studies of IoT in agriculture. Thank you so much, sir, for accepting the invitation. And
hello.
yes, sir.
So can I start now?
Yes, sir. Yes, sir.
Yeah. Thank you very much, Parikshit, for this kind introduction. So I'm sorry for the goof up at my end. I'm new to WebEx. I've not used it earlier, so there were some problems initially. I hope you are all able to see my slides. Right. So I'm going to talk about IoT in agriculture. And so let me, yeah. So the major problems as I see them in the agriculture domain uh, in the recent past. So these are some of the problems that I have been looking at in some context over the past couple of years. So a few things that I have come to my observation is that the erratic weather patterns due to global warming, so that has affected crops adversely around the world. And these erratic patterns are more localized. They are not like global patterns, right? So in some places they would have more effect, and in some places their effect would be very minimal. Then the other thing that I've been working on in the past is about post-harvest losses. So this problem is very closely linked to uh, uh, the problem of crop yield prediction. And crop yield prediction is not a very new topic, but there have been a lot of interest recently with a lot of people trying to use image analytics and deep learning to predict crop yield. And predicting crop yield has a lot of advantages. So it first thing what it does is it allows you to, like, if you can predict it in advance, not just a couple of days before the harvest. If you can predict it well in advance, then you can manage the post-harvest period very nicely, like storage and transportation and a lot of other things, and pricing also, right? So post-harvest losses are very kind of damaging to the whole system. So crop yield prediction plays a very important role. And then there are a few things about the complex agriculture supply chains. So here, especially in India, the supply chains are quite kind of unorganized, I would say. And what we can do in improving or streamlining the supply chains, agriculture supply chains in India, we have done some work on the milk supply chain or the dairy product supply chain. I'll be talking about that in today's lecture. All right. So later in the talk. And then farmer security and insurance. So it's a very major problem in India. And again, this can be linked to the crop yield prediction models. Like if you can predict the yields in advance, then you can accordingly decide the insurance premium and other things, and how much compensation a farmer gets in case his crop is damaged. And I'll show you one particular solution that is adopted in the US, where the farmer need not even file a claim for damaged crops. So there are automated systems which can completely take care of any kind of damage. And if the farmer is part of that insurance company, without even filing a claim, the farmer can get compensation. And then food security, food for all. So this is a very major problem that we are going to face in the coming years, coming decades, I would say, because the world population is expected to be around 9.2 billion by 2050. And so that is an additional 2 billion people to feed in the next 30 years. So it requires a lot of efforts in terms of increasing production, minimizing losses, less use of water, right, and other natural resources, reducing pollution. So all of that comes under this. So food security is very critical. And then again, crop diseases. So these are again more localized, right? So the kind of diseases that you have in one particular region may be very different from the other regions. So what there are two things which are quite local. So so there is a lot of importance we can attach to the localized patterns that are there. So in some terms we call it hyperlocal predictions or hyperlocal conditions. So I'll talk about this hyperlocal aspect in this. So there are two problems which are more localized than others. So let me now move to the next slide. So how IoT and other related technologies can help. So one major observation that I had about IoT and the IoT technology, that it is very important, but at the end of the day, it is just a data collection system. So it will just collect the data for you, and after that, what you do with the data is very important. So I'll talk about all aspects of this, right, and especially what you do with the data and what kind of analysis you can do specifically in the agriculture sector. And I'll also want to bring your attention to Government of India's current focus on agriculture. So recently we got, there was a document which was released for comments, a request for comments. So this was the Indian AI stack document, and it was released just in the last month, September 2020. And one of the things that I have mentioned in my agenda slide also, how AI can help in driving a food revolution to meet the increased demand for food. And according to some estimates, there are we need to increase the produce by 50% to cater to additional 2 billion people by 2050. And this study was done by a committee called as the AI Standardization Committee under the Department of the Telecommunication. And then there was another initiative of the government which was laid down in 2019, early 2019, and government has set a target of doubling a farmer's income by the year 2022. So this they call as the DFI committee, right? And a detailed report you can find at the link that is provided at the bottom of the slide. So DFI, so here they are trying to increase the farmer's income by a factor of 2. So these are the Government of India's initiatives and what they are looking for in the coming years. So let me take you to the next slide. So Internet of Things, as I see it, so I have been working in the area of data analytics for the last 10 to 15 years, and this is what I see as far as IoT is concerned. So it's a data collection network. So it's a network of sensors, which would interconnected sensors, which not necessarily interconnected, but they're all connected to the internet, and you can sense almost all kinds of data that you can imagine these days. And the data is spatiotemporal data. Spatiotemporal because these sensors are placed at different locations, geographical locations. They could be geographically distributed within a field, right? Or within a geographical area which is much bigger, like a district or a state, right? So spatial aspects come from there, and the temporal aspects come from the time period at which the sensors emit the data and it is collected at some server. And what kind of data can be sensed? As I said, that this sensor technology is advancing very, very rapidly. So almost all kinds of data can be collected, provided you have developed a suitable sensor for doing that. And what we can do with collected data, as I said, that has been my focus all through. So I'll talk a little bit about that as well. So then there was a term coined a few years back, and it was called as Internet of Agriculture Things, IOAT. So this was basically like, I'm sure those who are in the agriculture domain, they know about John Deere, and there are several other companies, similar companies, which are into infusing technology in the agricultural sector, and they've done a lot of things. So as you would know, that there are a lot of equipment that are being used in the agricultural sector, right from tractors, sowing machines to harvesting machines, sprinkler systems, cattle sheds, storage areas, warehouses, transportation vehicles, fields. I mean, the list is endless. So you can actually make all of these as sensors. I mean, you can attach sensors to all of these and collect data, whatever data you are interested in. And what is being sensed, I mean, again, the list is endless. Weather, soil, water, crop images, emissions, etc. All of these are being sensed, and at what frequency. So frequency means the time frequency. So this basically depends on the parameter being sensed. So there is no there may not be a uniform period at which you are sensing the data. And as I said earlier, also the data is spatiotemporal in nature. So whatever you do, if you are not exploiting the spatiotemporal aspects of the data, I mean, then we are not kind of exploiting the true value of the data. So sense and making sense, sensing and making sense. So IoT is all about that. IoT plus data analytics is like you sense the data, then you analyze it, and then you use it for taking decisions. So sense, analyze, decide. So that is what you do all the time, whenever you have an IoT deployment in agriculture or in any other domain. And big data analytics is at the core. So here we do many different kinds of analysis, like the spatiotemporal data analytics, so which requires you to model the problem in quite differently as compared to what we call as the snapshot data. So, and where there is no spatial aspects. So most of the things, most of the algorithms that have been developed are for snapshot data. So nowadays there is a lot of interest that is there in MVTS data, that is multivariate time series data analytics. So you build predictive models on top of this MVTS data that you are collecting through the sensors or through the IoT devices or networks. So this is important in the sense that what you want to do with the sense data. And as I said, I'll take you to a situation. And if you see this picture, so I've mentioned the source. So this is not a very new picture, but I think if you talk about India, this is still very far away from becoming a reality. So you can see this here, there's a farmer and he's in his field, and you can see that he has grown maize, and this maize got damaged because of unprecedented rains. And what happened after this was truly amazing. So if you see, a company tracks weather occurring on its customer farms. Customers means who have taken their policy by overlaying a map of the US over 8.5 lakh digital grids. And when the grid of the farmer Josh Norris in Middletown, Indiana, indicated that erratic rain has damaged his corn plants, the company was able to compensate him for $45,000 automatically for his losses, right? And Norris, the important thing is that Norris did not have to even file a claim for this loss, right? And the company name is Climate Corporation, and recently it has been taken over by a seed company. I'm not able to recollect that name. It starts with M, so they are into the seed technology, and they have taken over this to provide comprehensive solutions, end-to-end solutions to the agricultural sector in the US and many other parts of the country. So this is again about Climate Corporation, and they analyze weather, soil, and crop yield data from more than 30 data sources, and ingest 22 weather data sets every 6 hours, right? So, and creates 10,000 scenarios that could impact farmers for as far as 2 years down the line. So this means that they are trying to build scenarios that they are trying to predict what is going to be the situation for a particular farmer in the future. So that is what they call as scenarios, and accordingly they are intervening, and if the interventions are also not working, they are providing compensations. So Josh Norris was a very typical example, and this thing was there in the news for quite a long time. And the result is this results in 34 trillion simulation values used at hyperlocal. So this is what I was talking about. Hyperlocal insurance coverage from the financial calamity when bad weather hits. So hyperlocal. So this is an important thing. So it is mainly about the granularity at which you are working. So I'll talk more about this hyperlocal aspect of this. And before I give you more details, I would want to get into some statistics. So 50% of food ready for harvest never reaches the consumer's mouth. And this could be because of many reasons. So few of them I have listed here. One is insufficient storage. And this is very, very true in India. Like the warehouse capacity in India is very, very limited. And even if you have the warehouse capacities, the conditions there are not very conducive, right? So you cannot store your harvest for long periods of time in those warehouses. So that's a very typical problem. Only I think FCI and some NGOs have done have some warehouses, and so as compared to the crop yield, we do not have sufficient storage capacities. And then unreliable transportation networks. So people use all kinds of transportation to transport their harvest to the nearest mandis and markets. And the other worrying thing is like 70% of fresh water worldwide is used for agricultural purposes. So how this can be reduced, right? Because 70% of total fresh water, so that's a very, very staggering number. And another thing is that 90% of all crop losses are due to weather, right? So there is a need to monitor the weather at a local level, right? So that is very, very important, right? This is one thing that is coming out. The other thing is that if you can do something about storage and the supply chain, so you can do a lot of good to the agricultural sector. And out of these 90%, 25% of those losses can be reduced by predictive weather modeling and precision agricultural techniques. So some studies have done this. And on top of this, if you look at the global smart agricultural market, this is expected to reach around 15.3 billion by in another 5 years. And it was just 5 billion, so it has tripled it'll triple in almost 10 years, right? So that's quite a lot of money that is there in this market. So smart agriculture is going to grow very, very rapidly. So what needs to be done? So according to me, hyperlocal analysis of weather and soil and other conditions is going to be very, very important. And when you talk about hyperlocal analysis or hyperlocal data or hyperlocal conditions, then IoT is bound to play a very crucial role. So this is where I see the role of IoT becoming even more important than what it is now. So because you can sense data at any granularity as you wish, if you have access to what is called as affordable. So I'll talk about this affordable aspect of IoT later in my talk. So affordable IoT. So because see, in a country like India, which is very sensitive to adopting technology, and especially when the technology is expensive, right? So not many farmers are in a condition to adopt it, even if they want to. So affordable IoT is going to be very, very important, very, very crucial. So unless you are able to make this technology affordable, its deployment and adoptability will remain very, very low, and it will not benefit the farmers who actually need improvements and and they need support. And weather and soil sensors located at various places in the field can help this. So a lot of work is being done. So I can refer to one work that is being done in Pilani itself in the EEE department. So they have come up with a project called a Soil Talk. So here they are trying to sense the soil parameters using an IoT network. And weather, again, so this weather thing, we have to see how we can make it more affordable, like the sensors that we need and deployment aspect of IoT. So affordable IoT is something that we should try to work for. So I'll now take you I'll try to give you some idea about the kind of work that we have been doing in agriculture. So currently we are looking at deep learning based crop yield prediction models. And what we are doing here is that we are using image data. So there is a data set called as MODIS. So you can refer to this. I have some slides on this, which I'll talk about. And what we are doing is that, so MODIS is basically a satellite satellite imagery data, and it gives you certain kinds of indexes which we can use for figuring out how good or how bad the crop is in a particular area. Although its resolution is around 500 meters, but still it's a very good data set which can be used. And then we are also planning to collect data at a much lower altitude using the drone technology. So again, here we are trying to work with our colleagues from the EEE department and trying to work on this data, drone data. So our objective here in this work is to look at all kinds of data and come up with models, deep learning models, which can predict crop yield very, very accurately. So it is not just about using image data, but other kinds of data that is readily available these days. And as I said, MODIS data is a good starting point. And then there are other data sets. One is Landsat data, which can also be used. All right. So, and as I said, we have done some work on the dairy aspect, and we are here trying to improve the milk supply chain using confluence of technologies. It's not just about one technology. So IoT, we are also using blockchain and also AI/ML to improve the milk supply chain. I'll not be able to give you a lot of details, but I'll give you some details about this. So this project is under kind of consideration of AISRF. AISRF is for Australia-India Strategic Research Funding, round 12. And this we are doing with a university, in collaboration with the university in Australia, that is La Trobe University, and our Indian partners are IIT Kanpur. So let me give you some idea about this. And this work basically stemmed from the fact that most of the dairy industry is 50% of the dairy industry is unorganized. Only 50% is organized, right? And they are kind of in the hands of the private players, right? Like Reliance and many other. I think a couple of them are public sector companies also. So improving data-driven decision making in small and mid-scale dairy cooperatives. So we are targeting only small and mid-scale, because this is where there is very less organization, right? So it is very less organized. And what we are doing here is we are developing a smart sensor-based system to identify problems and strategies to improve milk quality. Basically, we are trying to improve the supply chain, the milk supply chain. So I'll give you some idea about this, right? And so this was again based on some observations that we had. So India is the biggest milk and value-added milk products in the world. So it produces around 146.31 million tons of milk in 2018. And 50% of the milk is sold in the market comes from the unorganized sector, right? And quality of milk is one of the challenges here. And okay, so this was one FSAI report in 2018, which said that 41% of the milk samples were found lacking in quality. And so this I've already discussed, so I'll skip this. So you can see here, so milk quality is a concern, and how we are going to address this in the unorganized sector. So I'll just give you a preview of that, right? So this, okay, so this I've already told you. So 50%, so main thing is that 50% of milk is in the unorganized channel. So this is what we addressed. And you can see here, so right from the farmer's gate, where this data is, where the milk is collected, right? And then it goes to the pooling stations, and then it is packaged, and then it is sent out to delivery. So this is the milk supply chain, as you can see here. So production, transportation, collection and processing, packaging, distribution, and retail. So we are trying to use IoT sensors at different points. So it is not, right now we are not targeting the transport part, but as soon as the farmer packs or bottles his milk in a milk container, from that point, and when it goes to the pooling station. So we are trying to track each and everything, all the parameters that are required, we are tracking. And so this is the complete thing that we are trying to do as far as the milk supply chain is concerned. And the same thing we are planning for the agriculture supply chain, especially in terms of fresh vegetables and fresh producers. So because they have very limited shelf life, so whatever whatever we learn from the milk supply chain, we can apply it to fresh vegetables and fruits in the vegetable supply chain or the agriculture supply chain. So let me take you to the next slide. Yeah. So for this, we have done what is called as primary data collection. And so we have identified a couple of states where we have our collaborators and other campuses of BITS. So we want to target around 30 to 50 farms across 3 states. And our data collection points are at the farm gate, cooperative or processing plant, and just prior to delivery and at the delivery points, like at the retail stores. This is what we are trying to do. So basically what we are trying to do here is that another objective of this project is to kind of replace the physical tests by doing soft tests, right, using the data that we are collecting through various kinds of sensors. So that is another thing. And then we are doing, as I said, this is the second objective. And for this, we are collecting data from IoT, right? So we collect real-time data. We call it the secondary data, right, on which real-time analytics can be performed. And here we'll also be assessing milk quality. And specifically, when you talk about pooling of milk at the pooling stations or at the cooperatives, right? So one bad sample is going to spoil everything. So we want to figure out, we want to predict whether a milk that is brought by a farmer is worth pooling or not. So all those kinds of things we'll do using different kinds of AI and ML models. And we are also going to do a lot of image analytics to figure out the quality of milk. And all the data that is sensed by the IoT, so it goes to a blockchain, so where it cannot be tampered with once it goes into the blockchain. So from that angle also, so tamper-proof data collection we are doing using this blockchain technology. So this is what is that project all about, and so this I've done already. Yeah. So we want to do some kind of predictions, shelf life, worthiness of milk, and any deviations in milk quality using images, which we collect using visual images, infrared, and fusion. So this is what we are doing in this project. Okay, so and we have done some earlier work, early, like almost 7-8 years back on crop yield prediction. Right, so this work was done in collaboration with the Indian Agricultural Statistical Research Institute, New Delhi. And so here, so we were looking at wheat crop, right? And if you remember, somewhere in 2009 or something, we had a major post-harvest losses of the wheat crop because there were not many warehouses where you could store your harvest. So there was like very huge losses that were incurred in the year 2009 or maybe in early 2010. I think it was 2010. March, April time. So prediction of wheat crop, and the objectives are to minimize post-harvest losses by having a better management and decide on farmer insurance, and not just farmers insurance, but also on the price of wheat. And we used meteorological data coming from different parts of the country. And again, we used the spatiotemporal, exploited the spatiotemporal aspects of data, and we used what is called as a multi-stage classification. So this multi-stage classification is that, say from sowing to harvest. So we don't just wait for coming very close to the harvest time to do the prediction. So what we do basically is that we start prediction almost like halfway through the crop cycle, and then we keep doing it at regular intervals of time. And we every time we hope that, so if this is the actual, so we'll kind of get close to the actual prediction. So we developed a model, this multi-stage classification technique, and I'll show you some of the results that we got at that time. So, and another data set that we used for this was the NC94 data set. So this NC94 is for the north central part of US. And it is a very elaborate data set, almost for 30 years. And there are a number of counties that are involved are more than 1,000, and the granularity of data for the meteorological aspect is at a daily granularity. So this was a very comprehensive data set which we worked on, and okay, and this. So I've just shown some of the meteorological data parameters here, not all of them. And so this is about the climate data. Then they also had what is called as the soil data, and it was more or less static, and it had almost 105 attributes. So, and then there was crop yield data. So crop yield data is shown in the next slide, so you can see this. So it was about many different kinds of crops, right? Although we focused only on wheat, and so the attributes are shown here. So, and these are the results that we got in terms of the loss functions. So you can see that as we do more and more training using more and more epochs, so we could reduce the losses. And then I have some results about some of the counties where the results were very good, right? So you can see that almost there is very less error, right, in all of these as far as actual are concerned. And this is for the year 1999, and this is for the year 2000. So what we did was all the previous year data prior to 99 was used for this purpose, and here we used 2000 and everything before that to build these models. And but these results were not good for all the counties. So for some counties we got quite a bit of error, so you can see here. So right, so this we couldn't get very good results for all the counties, but the good thing was that we could get results which were very good for some of the counties. Right, so now I'll focus my attention on our current work on crop yield prediction. So as I said, we are using image data from satellites, okay, and this data is called as the MODIS data. And we are also trying to collect data using drone technology, so that you get pictures of the crops from a lower height, and you can also do a visual inspection of those images. And then we are also using, we are not just relying on the satellite or the image data. We are also looking at the meteorological, we are clubbing it with meteorological and soil data for the same region. And MODIS allows you to get this data about get the image data for any area across the world, right? So it is it's a very nice data set. So if you have not seen this, please have a look at this. So you may find it very useful. And again, as I said, we are looking at spatiotemporal aspects of data. We are not overlooking them. We are not flattening the data in terms of time or space. So that is very important part in any kind of thing that you do in with spatiotemporal data. And as I said, IoT IoT data is inherently spatiotemporal. So you should not try to flatten the data. Like you say that if you get every month's everyday data at everyday granularity data for a month, so don't just take the average of all the 30 days and convert it into a snapshot data. So you lose all the temporal and spatial patterns, and also do not do away with the spatial coordinates or the spatial attributes that you have in your data. So those are very, very important, right? So whatever we have worked on spatiotemporal data, we have felt that any kind of flattening in terms of spatiality or temporality will have a very kind of adverse effect on the results. And then we are always doing a multi-stage classification. So because this always gives us confidence that as you move closer and closer to the harvest, your results are improving. So it gives you a lot of confidence in your models. And then okay, I still have time. So these are different kinds of products that you have for MODIS. So they have what is called as surface reflectance data sets, and they have VI. So this is what is called as a vegetation index data set, and there are quite a few of them here. Okay, so these are the different kinds of data sets that you can get in this, and you can so description of MODIS. So it is moderate resolution imaging spectrodiometer data set. Okay, MODIS. So that's what the name, MODIS. And it is called moderate resolution because it has got a 500-meter spatial resolution. So not less than that. Although we have another data set that is Landsat, right? So that is at a 30-meter resolution. Okay, right? So that also you can look at. So it gives you this particular product of MODIS Mod 13A1 version 6 product provides VI values at a per pixel basis at 500 meters spatial resolution. Okay, so they have developed some algorithms to kind of give you values for regions where I mean for final granularity data, so that you can use to get data for final resolution. So this is what it is. So they come in the HDF format, right? So you can look at this data. So if you are interested in satellite data, imagery data for crops, so you can, this is a very, very good source of data. So I think I'll skip this. So, all right, so you can look at it on your own. So because these are all quite elaborate, I'll skip on this part and description also. And so there are two things, NDVI, sorry, and this is normalized difference vegetation index. And it's a simple graphical indicator that can be used to analyze remote sensing measurements. Okay, and it ranges from -1 to 1. And then you also have what is called as, this is how we calculate this. And then we also have EVI, enhanced vegetation index, and its value is from 0 to 1. And this is the formula by which is calculated in the data set. Okay, I'll skip these details. So these are some working details of this. And this is how they actually calculate or they collect the data through the satellite, right? So I'll skip these details here. Okay. So now I'll take you to IoT research. So here I'll point you to some of the major problems as I see as far as IoT is concerned. So IoT research, so we should be able to develop new, cheap and robust sensors, because most of the time these IoT, specifically in terms of agriculture, So most of these sensors are deployed in the open, right, in open areas. So you need to be very careful about designing robust sensors. So if anybody is doing the instrumentation aspects of IoT, they should be very particular about designing robust sensors, because noise or noisy data is a big problem that is there uh, with IoT data, right? So IoT networks many a times give you data that is noisy because of some malfunction in the sensors. So it is very, very important that you develop sensors that are very, very robust and also cheap. So as I told you, affordable IoT, right? So affordable IoT is the is going to be very, very important. If you are not able to develop IoT networks uh, in a way, using very little amount of resources, it is not going to be acceptable. And you need to design sensors which can sense new kinds of parameters as per the application that you have. Then the second important research point or research bullet in IoT is IoT security. And I'm sure, I know one of my colleagues did talk about IoT security in one of the previous talks a couple of days back on IoT security. And then there is also another aspect that is very, very important is IoT privacy, right? Okay, so how can you preserve privacy when you are collecting data using an IoT network? So privacy is going to be very, very important. And if you now look at the research that is happening in AI and ML, so private AI is becoming very, very important, right? Or privacy preserving machine learning. And there is something, there's a solution that has also been proposed recently. It is about federated learning. Right? So here what happens is, so most of the time what happens in an IoT is that you have these sensors which are placed geographically, and they all upload their data onto a central server or a cloud, right? So this has two problems, right? So suppose this is one farmer, or this is another farmer, or these are organizations, right, which are collecting data through an IoT deployment, right? And they are all sending this data to the cloud. So there are two problems with this. Okay. So one is that you have to communicate your data to the cloud, and this data, as I told you, is not very small amount of data. It's a large amount of data. So you need very, very high bandwidth, right, to be able to load or upload this data onto the cloud or to a central server, right? So this is one thing. And then your data now goes into the cloud, and then you don't know who all are able to access this. Okay, so right, so there are these bandwidth issues, and then there are security and privacy issues associated with this kind of model, right? So we call it the centralized model, right? So where everything goes into a central server or the cloud, and then you are doing some kind of analysis on this data. So now with this private AI and federated learning, what has happened is that say you don't need to communicate your data. So your data resides with you only. Okay, so you don't do anything with your data. So only you will have access to your data. So what this central server does is that it sends out, so suppose I'm trying to build an AI model on this data. Okay, so what this will do, so this federated learning, or we also call it distributed learning. So what it does is, so let me use a different color to indicate what we do here. So in this case, the server or the cloud sends out a very primitive model, right? We call it the skeleton model, to all the sites, or you can say all the farmers or all the organizations that are involved. And then what they do is that this skeleton model is trained with the data that they have locally, right? And then this, again, once you have learned, or this model is trained at the local site, the model is communicated back, and right, and that too in a very secure manner, right? So nowadays there is a lot of work on homomorphic encryption. So that is one of the very secure way of sending the data back. And here we are not sending the data, we are only sending the model, and that too in an encrypted form. So I'll not get into homomorphic encryption at this point, but this is one very important area of research that can have a big impact on IoT and data analytics and AI research. And it is now solutions are being around federated learning models. So then this model will get back to the cloud, and then at the central server, these models are aggregated. And once you have done many iterations of this, right, then you freeze your model, and then this model is sent back to the farmer or to the organization, and then that particular organization or farmer can use that model, right? So that is what is very, very important nowadays. So this new paradigm in data analytics and in AI, and it applies to any kind of setup which is distributed in nature. And IoT is, as I said, it is implicitly distributed. So this you gain a lot by doing this. So there are two things that happen here when you use federated learning models or private AI models, is that you never communicate your data. Your data resides where it is, right? And only the model keeps oscillating between the central server and the sites, and that too in encrypted form, right? Okay. So this is a new thing, and we are trying to do, so this has got lots of applications in healthcare, because healthcare is one sector where privacy of data is of utmost importance. So healthcare applications are there, and people are now using federated learning in all kinds of sectors. So this is one thing, and we can also plan to use it in the agriculture. It applies very well to agriculture as well. Okay, so, and then the next thing here is, let's see, yeah. And then you need a very robust data analytics framework on top of IoT, any kind of IoT deployment. So that you can very quickly and efficiently analyze the data that you have collected through your IoT network. So unless you do a comprehensive analysis of your data, just having an IoT deployment is not going to help you in any way. So IoT data analytics framework. So according to me, so these are the four kind of bullets where we need a lot of research to happen in the coming years. And as I talked about, so let me remove these annotations. So as I talked about, so this affordable IoT is going to be the key for mass adoptability and deployment. If you are not able to provide cheap IoT solutions, mass adoptability and deployment will always remain an issue. So it will help those farmers who are already affluent, so, and who can adopt or who can buy this technology, right? Okay, so unless it goes to the grassroots levels, right, this is not going to help the community as a whole, right? And then what we have observed. So now I'll just take a few minutes to talk about what are our initiatives in this domain of IoT and other technologies, right? So one of our observations was that the problems that we are attempting to solve these days, they can come from, I mean, they can be from any discipline or domain, right? So these technology, these problems are becoming so complicated that one particular technology is not able to handle them properly. Like as I told you, in our dairy product, we have used AI/ML, we've used blockchain, we have used IoT, right? So we've used all three technologies. So we feel that combination of technologies is going to be required for solving problems that we are facing these days. And we have also included one more technology in our, so we have set up a lab, right? And this is going to be converted into a center of excellence with time. And so robotics and drones, like as I said, for our agriculture related problems, we are planning to use drones as well. So AI, ML, blockchain, IoT, and of course, whatever you do with these, ultimately you have to do some kind of analysis on that. So big data analytics is at the core of everything. So what we have done in this lab is, so we have set up this lab. So we are working on many application areas, niche application areas, which we have identified. Right? And these are the technologies, 4 technologies that we are working, 5 you can say if you consider robotics and drones as technologies. So we are working on food safety and security. We are also working on cyber security. We are working on smart cities and sustainable cities. Then biodiversity related problems, healthcare, and overcoming digital divide. So these are some of the problems that we are working on. This is again a very big problem, so but this I'll not be discussing at this point. So disruptive technologies lab in this, and this is what is the idea, that you will ultimately be having a center of excellence here where we will have these 4 technologies: robotics, Internet of Things, blockchain, and AI and ML. And at the core will, of course, be big data analytics, which is implicit. So that's why we have not mentioned, and different kinds of applications: biodiversity, agriculture, health, e-governance, smart cities, cybersecurity, also manufacturing, disaster management. So all kinds of application domains we are trying to cover under this. And then we also have another initiative at BITS. This is purely related to AI. So I just want to spend 1 minute on this. And so this is a center which we call as the App Care Center. So it is funded by the alumni. So Anuradha and Prashant Palakurti Center for AI. So this is initially this was set up in Goa, and now we are expanding it to all the 4 campuses of BITS. And so this is a center for AI research. And so this is the link that I provided to this. So we are doing a lot of things under this initiative as well. So see, what we are looking at is the conceptual AI, that is conceptual and theoretical aspects of AI, then applications of AI. This is where most of the focus is right now. Then we are also looking at the implementation stack for AI, and we are also looking at responsible AI. That is, you don't do things which are not ethical, right? So ethical AI or responsible AI. And we are also looking at another aspect of AI that is called as explainable AI. So how you are able to explain the results to the end users. So this is a new area, emerging area. I mean, not very new, but this is kind of gaining a lot of importance these days, because the end users are now questioning that what models you have built, how good they are, and how can we rely on those results that your models are predicting. So AI is not going to be a black box in the future. So you'll have to explain. You should be able to explain everything that you do under the AI umbrella, and you should be able to explain it to the end users. So that is what we are doing under this App Care initiative. So we call it the AI at BITS initiative. So I think with this, I'll conclude my talk, and I'll have another 10 to 15 minutes for question and answers, if there are any. Actually, I'm not able to see because of this presentation. So let me now end this show and just hello.
So much said.
Yeah, hello. So if there are questions, I'll be very happy to answer.
Participants, kindly unmute yourself and ask the questions. Meanwhile, I'll go through the chat and I'll. One is Mr. Krishna Samdani. That are there any source where we can get the various data sets related to IoT in agriculture apart from Kaggle?
As I said, there is this data set called as MODIS. Okay, so it is freely available. Okay, and okay, and you can access this from the Google Earth engine. So there is something called as Google Earth. Okay, and from there you can access this data set, which is called as MODIS data set. I gave you some idea about MODIS data set. It's again a satellite imagery data which can be accessed, and then you can localize it to any area that you are interested in by giving the longitudes and latitudes of that area.
Good afternoon, sir. It's Krishna Samdani here. Thank you, sir, for the informative session that we had right now. So I just have one more thing to ask. I wanted to know about a data set related to sensors, if by chance, if we have any similar kind of things for that. Not the image one, but yeah.
Yeah. So because see, these sensor deployments are very, very local. And and these are mainly with the companies. Like, as I said, most of them are owned by the insurance companies, these deployments. So not much data is available as far as IoT data is concerned.
Okay.
Right? But if you if you talk about so satellite data, there are lots of things. I told you about MODIS. There is also a Landsat data, which is at a much finer granularity, 30 meters, right? But IoT data is not readily available.
Okay. Okay. Thank you, sir.
Right. So there was some initiative long back, not long back, but IIT Bombay did some work in the field and they deployed sensors across agricultural fields, but that data is also not available in the public domain.
Okay. Okay. Thank you, sir.
Yeah.
Thanks.
I have a question. The question is very simple. It is not related to the research. It is related to the market, sir. The point is, the question is, how do we commercialize the thing? Because see, what happened, if we make a things and we make it into the academic, that is fine. And we publish it in the form of paper and it does not give any value. Yeah, I'm talking about in terms of money, not in terms of appreciation. Second point is, how do we change the mindset of the people? Because mindset plays a very important role. If let's say you make so many products for smart cities, for biodiversity, for agriculture and blah, blah, blah. But how do we access the people who are adopting this technology and make it in the form of comfort zone so that they will use it and they will generate the value in the society as well as to the government side? That is my question,
right.
sir.
So that's a very good question. So I refer to this particular problem in terms of affordability, right? So unless you are able to convince, there are two aspects to this. One is that the technology has to be cheap, or the product that you are developing has to be cheap. If it is not cheap, you cannot sell it in India, at least, right? Okay, so one is the cheap aspect, and second is that you have to convince people that it is going to help you, right? So that part is also there. So you have to somehow convince and educate people to be able to convince them to use that technology that is being developed. And you have to show them the benefit in terms of some tangible benefits, right? So in terms of money, because see, most of these farmers are kind of financially walking a very tightrope. So if you cannot tell them that this technology is going to help you financially, right, there will be hardly any takers. And this goes to, this applies to not just the agriculture sector, but to all other sectors. So affordability of technology is going to be the key. And you should be able to, or the government, I mean, I'm saying government has to convince people to use technology. So that is, these two aspects are really very, very important.
Sir, as I see, the mindset is the problem, I think, because mindset
That's
is
what
very
I'm saying,
important.
right? So that involves the mindset also, because see, I'm not convinced that something like this is going to work. So because these people are not very highly educated, right? So their education level is very, very kind of low, right? So most of them are not even school graduates. So it is very, very difficult to kind of convince these people unless you are able to demonstrate it. And right, so this is a challenge, right? I just mentioned about the affordability aspect, but this, yes, convincing people to use your technology, that's also a big challenge.
Good afternoon, Professor. I'm Mohan from
Yeah.
Bangalore. How the startups, so many startups are ready. With this example, AG Next, Aqua, Facel, these people are working in this area. Regarding insurance of the crop after using the technology, any remedies or work is there in this scenario, Professor?
See, insurance is always a very, very tricky issue. We have been trying to work with so there is an organization, government organization also, which exclusively works for the farmer insurance. But it is such a kind of a sensitive matter, and there are a lot of political angles to it also, so that it is very difficult to come up with insurance related solutions as far as farmers are concerned, because it is a big political kind of footprint. So I don't see anything coming out. Only thing you can do is you can support, you can provide data and results to these insurance companies, especially the government ones. But what happens after that, you cannot say anything. I mean, that is very uncertain.
Yeah, Professor, I have one more small question related to this. See, now government policy in agriculture, new bill passed, in that the farmer can sell anywhere his product. In that regard, the IoT can be added to do the sales business also with the IoT technology. Any of data collection is there. Which area where a good crop is available, that crop requirement at some other place can be added the IoT technology to that business statistics also now, Professor. What is your idea regarding this?
So for being able to tell that how good a product is, right? So you may not need IoT all the time, right?
That's my
So you can
idea.
just, yeah, I'm saying, I'm answering your question. So basically, what you can do is you can just have a picture of your product, and then that images are analyzed. So I'll tell you, there's a startup from IIT Kharagpur recently, right? So which does what is that clicks pictures of vegetables and fruits and other vegetable produce, and they analyze it, and then they decide on the price points, like something similar that is being done in the milk sector from very, very old days, right? So that kind of thing is definitely doable. You don't necessarily need an IoT infrastructure for this.
Yeah, thank you, Professor. Thank you very much.
Yeah.
This is the hyperspectral images. Are there any available data set for analyzing the crop quality by UAV cameras? Hello?
So
Hello. Yes, sir.
So are there any more questions, or if I have to look at the chat, can you please look?
There
I'm
is
not able to.
one more question on the chat. What is the difference between IoT privacy and security? Sometimes both seem similar.
Yeah. So see, security is more about somebody sneaking into the network and taking out the data, right? So how can you stop attacks on your network, right? IoT network to protect it from being stolen, right? Okay. The second aspect is it is not stolen, right? As I said that you send your data to a central server or to the cloud. Now nobody is stealing it, but your privacy is getting revealed to whosoever who is working with that data, right? So how can you protect that? So privacy is a different aspect or a different problem, and security is a different problem, right? Okay. So does that answer the question? Or and it applies to not just IoT data, it applies to any kind of data. So data security and privacy. So these are two different aspects.
Mr. Madhur Dev Upadhyay.
Yeah.
Madhur Dev Upadhyay. Does that
Yeah.
answer you? Sir has answered.
Yeah, sir. Definitely. This is perfect, sir. Sir, just means like you said, we upload some data on the cloud or some central server. So definitely, let's say I have some IoT system, my data is being, transferred or saved over the server, some server. So means there is a third party who will analyze my data. So if I would like to protect my data, means I would like to maintain the privacy, then I have to use some kind of password kind of something thing, so that a particular dedicated person can access the data. I think this is the right way to address the privacy.
So these kind of authentication based things have been there all through, right? And there are other techniques like you for protecting the privacy of people. You also anonymize the data, right? Okay.
Yes, sir.
So anonymizing techniques are also there, right? But now what the new thing, the new paradigm in this whole ecosystem is that you don't even need to send your data anywhere. Your data resides with you, right? So this is the new paradigm, and a lot of work is being done in this area nowadays. So it comes under federated learning or private AI and edge AI. So these are different names that are given to this particular technology. So you can look into these, and if you have any further questions, please feel free to come back.
So thank you, sir. Thank you so much.
Yeah. Thank you.
We'll take one last question, sir. Is there any source to get hyperspectral data from UAV?
So why would you need hyperspectral data?
Mr. Sudhir Kumar, are you there to explain?
Yes, sir, I am available.
Yeah, please.
Sir, I want to just know assess the quality of NDVI of various crops, or to assess the water stress level in the crop by finding the NDVI value. So this is something going on with the hyperspectral images to know the water stress level. So in this scenario, is there any possibility to get the hyperspectral image data of crops?
Yeah, so if you are talking about drones and all, so if you can have proper, the required cameras installed on those, I think that should not be a problem. I'm not into hyperspectral images. I have not looked at those, right? But I think infrared and other things we already do as far as drones are concerned, and any other imaging solution. UAVs we use very extensively for infrared images and other kinds of images. I have not worked with hyperspectral at all, so I will not be able to answer this question, but this should be possible.
Thank you.
So thank you so much, sir. First, I would like to thank sir for accepting our invitation. You were very kind, and since days of our association at BITS Pilani also, you have showered so much affection towards me. Thank you, sir.
Yeah, thank you very much, Dr. Parikshit, for giving this opportunity, and hope the participants would have benefited from this. And if they have any questions, they can write to me anytime, and I'll be very happy to answer their queries.
Thank you so much, sir.
Yeah,
So with this,
thank
we
you.
will end
Thank you.
this session, and we'll meet again at 2 p.m. Okay, then bye, participants. Thank you, sir.
Thank you. Thank you very much. Thank you.
Thank you, sir.